Okay, we're starting off the hour by reviewing what we did before, those CC over C kind of questions, and see if you can set up a 5-card hand where we have 3 aces and 2 eights. I'm going to pause for a second while you try that. So here's the 3 aces, 4 choose 3, and now this is important because and means multiply versus or would mean add, right? Okay, that's 4, and I'm going to label it aces and eights. It's called the dead man's hand. It's what Bill Hickok was holding when he died back in the Wild West. And this is for C2. Does anybody know what it's called when you have 3 of one thing and 2 of another? Full house. Very good. A lot of people, poker players in here apparently. All right. And that's over 52C5 because this was a 5-card hand. And some of you might be bothered by the fact that it's not balancing. I hope you thought about that. You're supposed to notice, wait a minute, this is supposed to balance. Do you get, we could have said there was 44 other cards and we're getting 0 of them. That way, look, it balances still. Does that make sense to you? And then the 3 plus the 2 does make the 5, but it doesn't hurt anything if I have this 0 there. It still makes 5. Does that make sense? Okay, then let me tweak the problem a little bit to make it a little more interesting. What's the probability that you got dealt either aces and eights, which means 3 aces and 2 eights, or eights and aces? I'll pause for a second while you give that one a try. All right, let's see if you knew what to do. I'm going to get rid of this because as soon as I do this next part, I was going to equal 1 anyways, and 1 times anything isn't necessary. And it's not going to balance anymore when you do this. It won't balance, and it's okay. It's just these are more complicated, so you have to deal. So now the eights and aces, I know some of you are like, it's the same thing. I heard people saying it's the same thing. You're right, it's the same thing. The probability is going to be the same because if I reverse these two and say that this is eights and this is aces, I'm still going to put 4C3 times 4C2. And so it's just 2 of them. There's the same thing. This is the same as this. And so didn't that double your chances? Yeah, and think about it. Now you can, quote, win with either aces and eights or eights and aces, and so you double your chances of winning. Can you imagine a casino where like they give out a big reward for that kind of thing? They actually have that. They have not necessarily the dead man's hand, but they have these rewards where if you get dealt a straight flush, then they give you like a prize. And it's not necessarily huge because they deal so many hands of cards that it happens, you know, not super often, but still. They might give you a cap. They're not going to give you like $1 million for getting a straight flush because it happens, you know, probably once a night, maybe even. Okay, so in case you don't know what a straight flush is, a straight flush is where you'd have a 4, 5, 6, 7, 8, for example, and all in the same suit. So it's hard enough to just get 4, 5, 6, 7, 8, but to have it all be in the same suit, wow, that's really hard to get. That's called a straight because it's the 4, 5, 6, 7, 8 thing. And by the way, it doesn't have to start with a 4. You know, it could be an 8, 9, 10, jack, queen, whatever. 5 cards in a row is a straight. And then it's called a flush if you have all the same kind of card. All right, let's just do one more like that. And for those of you that are not card players, there's 13 of each suit. So like hearts, diamonds, clubs, there's 13 of those. This time, because your homework does this too, I'm not doing a probability. You got to be able to shift gears. This one's how many hands are there, which means you don't divide by something to get a decimal, okay? How many hands are there when you are dealt 5 cards that will have all hearts? Well, how many hearts are there? And I'm going to choose to get how many hearts in my hand of 5 cards? 5. Raise your hand if you had 13, choose 5. Okay, awesome. So the problems seem really complicated, but there's a very easy answer. All right, let's do another one like that. Let's say in this room, all of you guys, we're going to be running for offices. Like somebody was going to become president, somebody else was going to become vice president, and somebody else is going to become treasurer or something. Okay? So president, vice president, treasurer. There are 26 people in this room, 26 kids. How many different ways could that happen? I know some of you are thinking, well, how many people are running for? You're all running for all 3 spots. I'll say it again. Don't overcomplicate this. There's 26 of you. How many different ways are there to choose out those 3 people? And is there an order? Is president above vice president? Is that above treasurer? Yes. Okay. So apparently, Mr. Server just switched it up somehow. What's different now? The order patters. You should have used a P. Raise your hand if you used a P. Okay, cool. And then it was 26P. Don't make this into a whole bunch of separate little things. It's just 26P3. That's it. Okay. Is that a big answer? It's 26 factorial. Let's stretch you. See if you remember what this is. 26 factorial over what? Because like you might be saying, I'm just going to use my calculator. Not if I make it 26PA. You won't. Dun, dun, dun. Yes. Yes. So then it's 26 factorial over 23 factorial. So it's really 26 times 25 times 24. Why am I not including the rest of it? That all cancels. All right, awesome. Then do you get why, if it was really 26 times 25 times 24, you could have thought of it as blanks and you were choosing and you were saying, how many choices do we have for this? And then why would we have less choices for this? Because you can't be president and vice president. You know what I'm saying? So then you'd have to have less people to choose from. And then when you get to the third one, you can't be, again, in all their spots. So therefore, there's only 24 choices left. So that's why we could think of this as choices. All right, one more time with the whole choices thing. Let's say that the 6 people in this row, we're going to line up and, I'm going to make it a little simpler. I'm going to pick the 5 people in this row are going to line up in front and have a picture. All right? Let's say I have 2 really tall people. Okay? If you're the tall person and you're taking the picture, you don't want to be like, boop, sticking up like, in a random place. It makes kind of draw attention to you. So maybe we should put the tall people in this group of 5 on the ends. There's 2 tall people. They have to be on the ends. There's still a lot of ways we could do the picture. How many ways could we do the picture? And again, use the blanks technique. Don't try to do this P this or that C that. Use blanks. I changed the problem from 6 to 5 people so that there would be a middle spot, but I'll talk about that in a minute. Okay, so we said there were 5 people, and the tall people had to be here and here. How many tall people were there to choose from? 2. And then if I chose one of them to be there, then there's only 1 left to go there. Is this making sense to you? And then there was 5 people total, so we've already used up 2 of the 5, so there's 3 left. 3, 2, 1. Raise your hand if you had that one right. Awesome. Now, since it's a set of 5, let's say that there's just one person who's really tall, and the rest of the people are kind of average height. Let's say that the one person out of the 5 has to be in the middle, because that'll make the picture look the best. Well, that one person, well, there's only one choice for that spot then. And then how many choices for this spot? 4. And then, okay. You multiply them all together because you multiply choices. All right. Remember how we kind of taught this yesterday? I was pre-teaching you so that today could be easy, and therefore today's pretty easy. All right, let's go look at the Schoology quiz right now. I'll pause for a second while we get there. Okay, we're in here in the thing called 5-9, combinations of probability, and here's the homework. Okay, so here we are in the questions, and we have 8 girls and 6 boys are in an art class. Hint, there is 8 plus 6, a total of 14 people in said class. What is the probability that 2 girls and 3 boys will be chosen to display their art? Okay, and then it wants 3 decimal places. So, if there's a total of 14, then we got 14 to choose from, and we're going to pick out a total of 3 plus 2 makes 5. Did you catch that? They never said that, but it's true. There's 14 to pick from, and we picked out 5 kids. Now the subgroups go on top. That's why I call it CC over C. The subgroups, there's always at least 2 subgroups. All right. Then this can be the boys, and this can be the girls, or the grills in that case, I guess. Sorry. There. Now the boys, there's 8 girls. I apologize. The girls are listed first in the problem. I will change to girls first. 8 girls choosing out 2 girls, and 6 choosing out 3. Okay. Here's your first one. Now, I want to use this as an object lesson on rounding. I got asked this like 5 times in the other class, so I should just answer it for all of you. Could you tell me what the decimal came out to? It's like 0.279 something, if I remember right. 2797. Now, since we have to round to 3 places, that brings up an interesting conundrum. You look at that, and everybody always gets confused by that because of the whole 9, and how do I round a 9 up to a 0? That doesn't make sense. Think of it this way. Would you agree that's 279? Think of it that way. 0.279. What's next after 0.279? 280. So it is 0.280 or 0.28. And it'll accept either one. Now, I know some of you were like, but it has to be 3 decimal places. Yeah, and technically they could have got you on that, but the answer key has all 4 possible answers. 0.28, 0.28, 0.280, and 0.280. So those are called different, well, it's technically aren't permutations, but just different ways to write the answer. Okay, cool. You got the first one done. Let's move on to the next one. Right away, they switch it. Notice it's still a probability. It's the next one after that that's not a probability. What's the probability you are dealt a 5-card? Ooh, we just did this one. 5-card hand consisting of 3 clubs and 2 diamonds. Now, some of you got so patterned on the card ones that you're going to think there's 4 clubs to choose from, and no. Do you know how many cards are clubs in a typical deck? 13. So you have 13 to choose from. So when you set this one up, make sure you start with 13 clubs, and you're choosing out 3 of them, and it's CC over C. Remember to get your decimal and put it in as a decimal. This next one, I had a ton of people asking me about it. It's one of those ones that seems really complicated, but the answer is really simple. You know, like 4P3, except that's not the right answer. But don't overthink that one. There is not a ton of separate numbers of people running for this office. It's just all one big class, and that's why I practiced that in class with you, to hopefully keep you from having confusion on that. Okay, so there you go. That's your homework for tonight. All right, one last thing. I want to introduce you to something because, I don't know, there hasn't been a great moment to bring it up until I happen to be using it in my other class. How many of you guys have heard of Wolfram Alpha? Okay, only one or two people. That is the Google for math. You know how powerful Google is, right? I mean, you use Google all the time. This is the Google for math. What I think is cool about it is you tell it something, and you know what? I'm still recording, aren't I? I don't need to record this because it has nothing to do with your lesson for today, so I'm going to stop the recording here.